So today is day 4 of Unit 3. If you are not on page 169, please get there. So today we're going to talk about writing algebraic equations. Now this might sound like something we've done already in this unit. You would be correct. But what we have already done is writing algebraic expressions. So the only difference between an algebraic expression and an equation is that an equation has an equal sign. Okay, that's why it's called an equation. So that's basically the only difference. Okay, we're going to still use all of our keywords. So an equation is a mathematical sentence that has an equal sign. Equation, equal sign. Okay, think about it, it makes sense. So an algebraic equation contains at least one variable. That's what makes it algebraic. Okay, otherwise it would be called a numerical equation. So if I were to give you 3 plus 4 equals 7, then that would be a numerical equation, whereas an algebraic equation has to have at least one variable. Okay, so example number 1. The other thing I wanted to remind you is, let me find it. So earlier in this unit I gave you this thing, okay, words and phrases, math symbols. This paper is super helpful. Also points out all of, well, I won't say all, but a lot of the words that would mean equals. So if you see any of these things, is, are, were, was, anything like that, that should symbolize to you that we are going to have an algebraic equation rather than an algebraic expression. So example number 1. Now notice with a lot of these examples and most of these examples when we are writing them, so honestly I shouldn't say most, I should say all. Okay, all of these examples are basically word problems, right? So the number one thing we have to remember when we're doing our word problems is to pull out the important things, which is what they've done in the steps for you already. But it's also good if we do it ourselves. So Nicholas has 28 coins. Okay? That is 4 more than his brother Sam. So we have to write an equation. So again, 28 coins is what he has. Is represents an equal sign. And then 5 more than Sam. Remember the word more than, that means that whatever the expression is, so if you notice this is an equation, but this, right, these two things, this would be an expression. So it's basically like 2 expressions are equal to each other, okay? So 5 more than Sam, remember we have to kind of flip this order, it's kind of like less than, so S plus 5. Remember we can't have less than or more than if we don't have something to begin with. Another thing to remember is that equations are equal to each other. So they're saying 2 things are equal. So if you wrote S plus 5 equals 28, that's the same thing. Okay? So either way, those are the same thing. So the equation 28 equals S plus 5 represents the number of coins that Sam has. So remember, always look back at what the question is asking. It wants to know the number of coins that Sam has. So once you're done, make sure that you've successfully answered the question. All right, example number 2, Mr. Edwards purchased 3 bags of potatoes. Okay, so he purchased 3 bags of potatoes. He bought 36 potatoes in all. Each bag contains the same number of potatoes. So this right here, these 2 things go together. Okay? So there are 3 in each bag. There's 3 bags, and each bag is represented by a variable. Okay? So what we want to know is we want to know how many potatoes there are in each bag. So in order to do this, I know I have 3 bags, and I have a total of 36 potatoes. Now I know that a lot of you would know, okay, well 36 divided by 3, that's how many are in each bag. But what we have to do is think about what you would do and kind of work backwards. So really I'm saying 3 times what equals 36. Okay, think back to elementary school. We did a lot of stuff like this, right? But now we're not going to use question marks. We're actually going to use variables. So variables are going to take the place of your question marks. So instead of writing 3 times blank, or a question mark, equals 36, we're going to give that a variable once we know what we're talking about. So we're talking about potatoes. So this right here, this is called your let statement. This is very important. This is what we teach in algebra as well, which is what we're doing right now. Okay, so it's always important to let us know what are you representing by your variable. What does your variable represent? This way, when you solve your equation, which we'll do in a later on in the unit, when you solve it, you know what P stands for, because it stands for something. It represents something else. So this equation would be 3P is equal to 36. Again, is, think of how you would say it. Is means it's going to be an equation instead of just an expression. Okay, so Phoebe is, right off the bat, I know that means equal, 3 years less than half her brother's age. Okay, so remember, less than means subtract, but it also means I'm going to reverse the order. Alright, so if we shoot down right here, so okay, we pointed out the things that we need to take out. Okay, so underline, and then if you need to, rewrite them. Okay, Phoebe is 13 years old. Her brother is B years old. These are the important things. So we want to figure out what is her brother's age. Okay, her brother's age is represented by B. So again, I pull out all the important information, and then I break it down. Okay, you're using the same exact knowledge that you used when you were writing algebraic expressions, but now we're setting it equal to something. So it says that Phoebe is 13 years old, but her brother is 3 years less than Phoebe is 3 years less than half her brother's age. Well, I know that she's 13, so then this part, this is the important part right here. Okay? So the only thing I can add right here, I'll just say this is a B, and then you guys should all do that. Okay, so this right here is the important part of the expression, and then we know that Phoebe is 13. Okay, so we're trying to set them equal to each other. We're trying to take her brother's age and manipulate his age so that we could figure out, okay, if Phoebe is 13, how much is her brother based on this? Alright, so I take half of the brother's age and I subtract 3 and set that equal to 13. Alright, example number 4. And again, I haven't mentioned this before, but percents, we're going to spend a little bit of time actually in class doing some group work with our percents, because I know that that is a struggle. But remember, whenever you see a percent sign, you should automatically be thinking, ooh, let me change that to 0.05. Okay? Because we want to do that because we don't multiply, add, subtract, whatever. We don't do that with our percents. Okay? So Raphael's tennis racket costs 5% more than Carl's tennis racket. Raphael's cost $126. So I know that on one side I'm going to have equal to 126. On the other side, I'm going to have, so C is going to represent Carl's tennis racket. Okay? But it says more than. Now, here's the thing that I want you guys to remember. Okay? Think about saw when we did our ratios and percents. Okay, so if we were trying to figure out how much a percentage is, we would multiply that percentage by the total number, and then we would end up adding that number to the original cost, right? So what I want you to notice in this is, so Raphael's cost is 5% more than the 100% cost of Carl's racket. So Carl's racket is going to be C, and then 5% of C is added to his racket. Okay, so let's look down here. So all percent problems are always like this. Okay, you're going to take the percent and you're going to multiply it by the cost of whatever we're talking about. In this case, we're talking about a tennis racket. Then you're going to add it to 100% of the cost. So you always should end up with a number like this. Okay, this should be, when you are doing percents, you should always have them broken down like this. Okay, because basically what they're doing is they're giving you all the steps that we would normally do, but they're mashing it all together into one. Okay, so they're combining like terms, like we did in the previous lesson. Right? So our final equation is going to be 1.05c is equal to 126. Okay, and now if it was less than, we would just do a simple subtraction. So it would be c minus 0.05c, which makes sense because if I had 100%, remember 100% is equal to 1, right? Well, I'm 5% more. So 5% more, that would be 105%, which is equal to 1.05. Okay, so that is why that is our final answer. Okay, and then again, we just set it equal to 126, which is the price. And for our last one, Nigel went to an ice rink and paid $5 for an admission plus an additional, so $5 plus an additional $2.50 per hour. If I go right here, it tells me to use H. Okay, and the total cost, so this all equals 15, right? Okay, so let's rewrite this. So I've kind of broken it down for you already, but this makes it even easier to break it down further. Okay, so nothing is being added to the 5. Okay, so if I translate this, this is just $5. Think if you go somewhere, right? You're only going to go in once. They're only going to charge you once. So that would just be a $5. Okay, and then we are going to add 2.5h equals $15. Okay, so 5 plus 2.5h equals 15. This is how we can figure out how many hours Nigel rented the skates for. Right, and that is the end of how do we write algebraic equations.